Hello everyone, my name is Barbara and I would like to welcome you all to our latest Novedge webinar episode. In this week's episode, Additive and Subtractive Manufacturing using VisualCAD CAM 3D Print. Stay with us for an overview of MecSoft's new released Additive Manufacturing Visual 3D Print product and their flagship VisualCAM Subtractive Manufacturing software solutions. This product suite features 5 modules that are fully integrated into one CAD software-based platform, VisualCAD. While sold separately, the modules include Visual 3D Print, VisualMILL, VisualTURN, VisualNEST, and VisualART. In this webinar, we'll be showcasing each of the modules and demonstrating the new features and functionality. Today's presenter, Uday Honnalagere, is the Technical Support Manager at MecSoft Corporation. He started as an application engineer and has been with the company since 2005. He is responsible for providing technical support and training for end users. Uday holds an MS degree in Industrial Engineering from Arizona State University, majoring in CAD/CAM. Before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's need. Put us to the test and come visit our webpage at novedge.com. And for more daily software news and limited time promotions, pay a visit to the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, Organic Surface Modeling in SolidWorks with award-winning Power Surfacing from NPower Software. Power Surfacing provides organic Class A surface modeling in SolidWorks through an innovative unification of sub-D modeling and SolidWorks features. Last but not least, today's webinar is free and is being recorded live. If you want to rewatch this or any webinar episode, just head over to Novedge's YouTube and Vimeo channels. And now, without further ado, I'm going to pass the baton to Uday, making the presenter, and he will lead the show and it will guide you through the new feature of VisualCAD CAM and 3D Print. Uday, just, yes?
Thanks, Barbara, for the nice introduction. Hello, everybody. Good morning, good afternoon, or good evening, folks, wherever you joined us from, and thanks for taking the time to join us for the webinar today. Today, we will be showcasing our flagship VisualCAD CAM 3D Print product and also our plugins for Rhino, which is Rhino 3D Print and RhinoCAM 2015. Currently, I have the VisualCAD CAM 3D Print product loaded, which runs inside our VisualCAD interface. And VisualCAM is offered in different modules. We offer milling, 2 to 5 axis milling solution, 2 axis turning solution, nesting of 2D parts, and also an art module. We will be focusing on what's new in 2015, and also we'll go through the 2 to 5 axis milling features in the CAM module, and then we'll also look at the 3D print solutions that's offered by MecSoft. I currently have the MILL browser loaded, so as I select VisualCAM and MILL, it displays the MILL interface. The MILL interface has 2 browser windows. You have the machining browser and the machining objects browser, which are docked right below each other. And the machining operations browser has 2 main tabs, Program and Simulate. VisualCAD offers a wide range of translators. You can bring in files into VisualCAD from different CAD systems. So we read 3D system file, 3D studio files, AutoCAD DXF, IGES, STEP, STL, SAT files, SLC, and a whole bunch of other file formats. Today, what I'm going to be demonstrating here first is to showcase the power of 2.5D milling operations and the new hole feature detection methods that were introduced in the 2015 version. So without any further delays, I'm going to get started in programming this part. Step 1 in the Program tab will define the machine tool to be programmed here as 2, 3, 4, or 5 axis. So for this particular part, we will pick the machining type as 3 axis. And then we can select the post processor. VisualMILL includes a wide range of post processors, which include posts for over 250 different controllers, and it's all available to you right from the current post processor list in here. In the next step, we'll go define the stock materials. So we'll select stock and box stock. So this allows you to define the stock material in here, where you can specify the length, width, and the height of the stock geometry. So when you select copy model bounding box, it automatically determines the minimum stock size that's required to mill this part. We will now go ahead and program some toolpath operations in here. So I'm going to go ahead and enable some of the curve geometries which I've already pre-created on this model. I'm going to start out by first facing this part. So I'm going to go to two-axis milling, and you'll find that the two-axis offers a wide range of methods, right, starting with facing, pocketing, high-speed pocketing, profiling, V-carving, engraving, chamfering, hole pocketing, hole profiling. This is one of the newer methods in 2015, thread milling, T-slot machining, and remachining. So we'll try to cover a few of these methods for programming this part here. So first, I would like to start out with the facing operation. So I'm going to pick two-axis and facing. I'm going to pick the geometries for my drive regions. I could either select surface edges or curves or sketch geometries from the 3D model. Select the features from the tool tab. I can select the tool from my library. Feeds and speeds, I can have it load automatically from the tool, or I can use load from file to have it determine feeds and speeds based on the tool and the stock material. The clearance definition allows you to specify your clearance plane for any transfer moves and non-cutting motions to safely clear the stock or the part max. In the roughing tab, we'll go ahead and specify the parameters for the facing operation. And in the cut levels, we'll pick the depth to determine the total cut depth. So I'm going to pick the depth of the 3D model right in here. And also I'm going to specify the location of the cut geometry to start the cuts from the origin, which is going to be Z0. And we'll now split this up into two levels, a 1/4 inch per cut, and then pick generate to create the toolpath. Now there's your roughing toolpath, facing operation. You can look at the toolpath display in levels. And now let's go run a verification by going to the Simulate tab. We'll click on the operation and hit the play button to run the material removal simulation. You can also toggle the display of the holder and the toolpath visibility as you run the simulation. You also have additional controls to pause and also simulate to end. So we just basically face it down to the top face of the part. We would now like to go ahead and program the pocket in here. So I'm going to use two-axis milling, and we'll pick high-speed pocketing. This is one of the new methods that was introduced in VisualCAD CAM and also in RhinoCAM. So I'm going to pick my drive geometry here. One of the advantages of the high-speed pocketing is it creates constant tangential arcs on your toolpath. So it basically gives you constant cutter engagement. So this allows you to run at much higher feed rates, which prolongs tool life. So as we go and set up the parameters for cutting here, I'm also going to go pick the depth of the 3D model by just picking any 2 points to define the total cut depth. It's going to be 1 inch, and let's split it up into 4 passes, 1/4 inch each. And of course, you can control your entry and exit parameters, and then select Generate to create your toolpath. So when you toggle the toolpath display, you can see that the toolpath for high-speed pocketing is formed with constant tangential arcs. It starts out at the spiral path and creates tangential arcs, which basically leads to constant cutter engagement and results in, much finer finish, and you can run these at much higher feed rates. So I'm going to hit play to run the simulation of the high-speed pocketing toolpath. So since the part is prismatic, you could program most of these features using 2.5D milling, as there aren't any negative drafts or there aren't any sculpted bottoms on these parts. You could program using 2.5D milling. Now let's go ahead and pocket these features in here. So I could go up to two-axis milling and pocketing to program these, or I could even bring in a knowledge base of machining operations which may have been already pre-programmed, and I can go ahead and load these knowledge base of operations in here into the part and select those operations for programming it in here. So I'm going to grab this knowledge base of operations, and let's say I want to use one of the pocketing operations. Just do a simple drag and drop from the knowledge bases tab into the machining browser. Then I'm going to go pick the machining features in here. I'm going to go select these through holes for pocketing. And as you notice here, the knowledge base automatically brought in the information in your tool, your feeds and speeds, your clearance geometry, as well as all your cutting parameters in here. And if you need to make any changes to any of these parameters, you can go back and reselect those depths. For example, I can go back and pick the depth of the 3D model, and then pick Generate to create my toolpath. So there is the pocket operation for the through holes. There they are. In the next step, I would like to go ahead and program these pockets in here. So I'm going to repeat the same pocketing operation. So I'm going to use the knowledge base functionality to drag and drop some of these operations in here. And also, rather than picking each of these features individually, I can use select predefined to go select a predefined set of machining regions that could be derived by selecting flat areas, or it could be derived by using curves or face edges. Now let's go ahead and select all of these predefined regions. We'll pick a tool for it, specify the cutting parameters, and pick generate to create the toolpath. So there's your pocket operation. So likewise, you could program the other features as well. Now, one of the powerful features I would like to show that's been introduced in the 2015 release is detection of hole features and machining them automatically with a single button click. Now, these features can be accessed under the Features tab. So I'm going to click on the Features tab in the Machining Objects browser. And first, I need to create or detect the features. I'm going to click on Create Hole Features. I'll pick the face on the top face of the part and press Enter. So this automatically detects the hole features on this particular face. And now I want to create toolpath operations. So I'm going to go ahead and drag this browser over to the side here. So you'll notice that with just one button click, the system will automatically create operations by looking at from the matching knowledge base. And you'll see that in just a moment, there is a whole feature operation program, the drilling operation program for this feature. You can go back and edit these to change any of your tool properties in here. If you need to modify a tool, your feeds and speeds, your current parameters, you can change that. And you can also view the cross-section of the feature, which shows the diameter and also the depth of the hole being milled. Now, to finish the part, I'm going to use a profile operation in here. So select two axes and profiling. And I would like to use a predefined region, pick a curve region from the model, and specify a tool for it. So I'm going to use a 3/8 inch end mill. For the cutting parameters, I could choose determine the direction of cut using a 3D model. So the system automatically determines where it's safe to cut the part. In the next step, I'm going to go to my cut levels to pick the total depth, pick the depth of the 3D model, and then specify the depth per cut in here. And finally, you can choose your entry and exit parameters. You can choose how you want the cutter to lead in and lead out, and apply these for each cut level and pick generate to create your toolpath. Now there's your profile toolpath, and you can go to your simulate tab to run the verification of these operations in here. You can always select pause and hit simulate to end to run through these operations as well. So once you have these operations programmed, you could go ahead and take a look at the estimated machining time for it. Right-click on Information, list the total machining time, and finally, you could do a post process to post it out to your machine controller. You can select your current post processor from the list of posts, specify your posted file extension, and selecting post will display a posted output file, and this can be transferred out to the mill. You could also generate a shop documentation. This allows you to create a setup information sheet, which basically provides information on how to prepare the part for machining, so you can hand this information out to the operator in the shop floor who can get all the tools prepared, the stock information. All of this information is available to you in the setup information sheet, and there's two different templates you could choose from, and you can see that it displays the image of the part geometry, lists all your tools, and each operations can be viewed in the setup information sheet. This is very useful for generating reports as well. It gives you the estimated machining time per operation and also the total time for all the operations. Now once these operations are programmed, you could also save these operations out to a knowledge base which can be further used on other similar parts. Now I would like to go ahead and show you some of the other nice features about the hole feature detection. So I'm going to go ahead and pull another part in here. So here's another part which is loaded, and you can see that the part has a counterbore and through hole. Now let's go into the Features tab, try to detect the features. I'm going to click on Create Hole Features and just pick on the space and press Enter. You'll notice that the system automatically detects even partial holes and as well as through holes. So you have an option to filter out what type of hole features to detect. So if you select include partial holes, you can automatically detect partial and through holes. You can also use the diameter filter range as well as the depth filter range to detect these holes. Now once these features are detected, I'm going to use the one button click operation in here to automatically locate operations that were saved to a knowledge base from the machining features, and you'll notice that it automatically created two operations. We have a standard roll and then a hole pocketing operation. So you can set up these knowledge bases for different parts that have the same or similar hole features. Now how do we go about creating these knowledge bases? We can select what's called create hole feature machining operation, and this brings up this interface which allows you to pick and choose the type of operations. Now let's say, for example, for the hole feature that's being detected, we would like to program a centered roll. I can just simply drag and drop the operation, and let's say you want to do a deep drill and also a hole pocket operation. So you can drag and drop these operations, and as you select each of these operations, it displays the information about the total depth and also the diameter of the hole at each cross section. So let's say, for example, for the centered roll, you'd only want to go all the way down to the counterbore. For the deep drill, you want to make it go all the way to the final depth of the through hole. And for the hole pocketing, we could set the same parameters in here to only cut the counterbore. And then we'll click on Create Hole Feature Set. It'll basically create these operations which you can then edit and generate toolpaths. Selecting Save as KB will save these operations, so you can use the operations automatically with a single button click to generate toolpaths for identical features on other parts. I'm going to click on Create Hole Features, and you'll now notice that these three operations have been created. You can go back to your Tools tab and pick and choose to drag and drop tools. So for example, you may want to use a 1/4" drill for your center drill and a deep drill operation, and a flat mill for your hole pocketing operations. And now you can go back and take a look at it, make any edits as needed, and then generate those toolpaths. Next, what I would like to showcase is the power of 3D milling in VisualCAD CAM. So I'm going to go bring in a 3D model, and we'll generate some toolpaths for it. There we go. So as you can tell, the part has a lot of features. You have sculpted surfaces, fillets on the model, radiuses on the part, so which you'd like to program. So parts like these can be easily programmed using 3-axis machining operations. So first, I can either use the existing tools I have loaded in my library, or I can load new tools by selecting Load Tool Library, or even select tools from my library. Next step is I'm going to select the operations to program, since I already have defined my stock and the work origin has been set to the lower left corner and the bottom of the material. I'm going to pick from the available 3-axis method. So VisualCAD CAM offers a wide range of 3D toolpath methods. I'm going to first start off the roughing toolpath. So I'll pick 3-axis and roughing. I'm going to go grab a tool for this. So we'll grab a 3/4" end mill. We'll plug in the feeds and speeds and clearance parameters. Specify your cutting parameters for the roughing process in here. You can specify your stock allowance, choose your cut parameters, and also specify your cut levels where you can control how fine you want the cutter to step. And selecting Generate automatically creates your toolpath by analyzing the part and the stock geometry and creates your toolpath. The system automatically determines the toolpath based on your part geometry and the stock geometry. There it is. There's your roughing toolpaths, and you can view the toolpaths in levels as you step through each of these levels. You can switch over to the Simulate tab, select the operation, and click on the play button to run the simulation, run your verification. You can always do a pause and also simulate to end to run through the simulation. Now once it's roughed out, we can go ahead and program a pre-finishing operation. So we'll go program a 3-axis and a parallel finishing. And I'm going to pick a containment, so I would like to contain my cutter just inside this area. So I can either select curves or face edges from a 3D model, specify a tool for it. So we'll go with a 3/8" ball mill. And then in the cutting parameters, you can control your step over and also your angle or the direction of cut. And selecting Generate creates a toolpath. Now I would like to then program a pencil milling operation or pencil tracing operation, this allows you to automatically go and clean up areas where the previous toolpath left scallops based on the finishing toolpath that you ran. So this basically automatically identifies bitangencies on the part and generates a toolpath to create a finishing operation. So I'm going to pick a 1/4-inch ball mill for this application and then pick generate to generate the toolpaths. So VisualMILL's 3-axis offers you a wide range of different 3D toolpath methods. Now let's go ahead and run a simulation for these operations in here by selecting play. You can run a simulation, shows the material removal for the parallel finishing, and there's your toolpath. And look at the nice finish on the part that you can see. You can also toggle the display of the toolpath during simulation. And of course you can hit the pause button to pause your simulation and click on simulate to end to run through the simulation. So there are several different operations that you could program to program these widgets. Now while we are waiting on the simulation to complete, I'm going to go back and switch back to the other part we started out with, and let's take a look at some of the other methods where we offer additional methods like 4- and 5-axis milling. So I'm going to give you an example of 5-axis milling in VisualCAD CAM. So in this example, what I'm going to be demonstrating is how to program a part from multiple different orientations using index 5-axis, or also known as 3+2 or picture offsets programming. So here's a part where you have features that needs to be milled from the top, from the front, and the side faces. So you can define your machine tool as 3, 4, or 5-axis and pick the configuration of the machine tools. In this case, I've chosen 5-axis and the machine configuration is head-head. We do support several other configurations, and we would be able to program these using a combination of 2.5 and 3-axis operations for programming index 5-axis. Now we've set up the orientation of the coordinate system to be normal to the top face. You can use these controls in the setup tab to orient your coordinate system to be normal to the side faces as well. So once you have it oriented, you could program your machining operations for the top face. So we now have operations, roughing and finishing operations and drilling operations for the top face. We would then orient the coordinate system to one of the side faces or the front face, and then repeat the same process for programming it from additional sides. And once you have these programmed, you can go ahead and run a verification of these. You can run each setup independently, or you can select all of these setups in here by holding the Shift key. You can select all these setups and hit the play button to run through the simulation. And also additional simulation controls are available to pause and simulate to end as well. So this kind of basically gives you an overview of the different types of 3-axis, 2.5-axis, and index 5-axis methods that are offered in VisualMILL. VisualMILL also offers simultaneous 5-axis milling methods where you could use true 5-axis milling for different applications. Now the same set of features are also available in RhinoCAM, so I'm going to switch over to the interface in Rhinoceros and give you an overview of the RhinoCAM product. So I'm going to select RhinoCAM and select Mill, and this basically displays the CAM interface in Rhino and looks exactly similar to VisualCAD CAM, except it runs completely integrated in Rhinoceros. So you can use the exact same workflow as you did in VisualMILL to work it inside of Rhino as well. So I'm going to go back to the same example we worked on earlier. So I'm going to grab this model, which is the core box, and you'll notice that once the part is loaded, you can work through the CAM interface of defining your stock geometry. You could then program your toolpaths. You can go to 3-axis and roughing operations. You can select the machining geometry. You can specify your tool, plug in your feeds and speeds, your cutting parameters, and then pick generate to create your toolpaths. So the system automatically determines the toolpath based on the part and the stock geometry. You could also load knowledge bases of operations which you program on your other parts. Let's say, for example, you had it programmed in the standalone system. They're interoperable, so you can bring it into RhinoCAM and generate toolpaths as well. So I'm going to go back and load the same knowledge base in here, and I could use the operations from it. So I could say I want to grab the parallel finishing operation, which I programmed in the VisualCAD CAM system. I can bring it into the RhinoCAM system and select those features and generate toolpaths for it. So this basically shows you the ability to being able to transfer data between both the CAM systems, between VisualCAM and RhinoCAM, and you can use the same workflow to program toolpaths in 2.5D, 3-axis, 4 and 5-axis as well. So I'm going to bring in an example here which shows some 2.5D milling, and it will also then take a look at turning in both RhinoCAM and VisualCAM as well. So we'll take the gear housing model we just worked on in VisualCAD CAM. So let's go ahead and load my knowledge base of operations in here. And this brings in all these operations. And let's go ahead and generate some toolpaths for it. So I'm going to do a drag and drop, right-click and regenerate. So with just a few button pokes, you have your toolpaths now being generated inside of Rhino using RhinoCAM. So the knowledge bases and also the operations can be shared between the two systems. Now I would like to showcase the same hole feature detection in here as well. So you can click on detect hole features, pick the face on the model, and it automatically detects those hole features. And either you can use the create hole feature machining or use the one button click to automatically generate the toolpaths as well. So the same workflow works in RhinoCAM as well as you noticed in VisualMILL. So we would like to go ahead and do the hole feature detection on this particular part in here. So click on detect hole features, we'll pick the face, right click to accept it, and you can see that the feature has 6 instances, and it lists each of these instances in the hole feature tree. And if you'd like to exclude or delete any of these instances, you can select them and hit delete to delete them out. And then I'm going to use the one button click here to select matching knowledge bases and automatically create the machining operations. You'll now notice that these machining operations have been created automatically in your machining browser in RhinoCAM. I would also like to demonstrate one other very nice feature that's available in RhinoCAM is the interoperability, where you can take machining operations programmed on one part and you can save the CAD data and the machining operations to a VisualCAD format, so which can then be loaded in the standalone system and generated. Also, multi-threading is offered in RhinoCAM and VisualCAD CAM. This allows you to generate toolpaths in multiple threads. So when you have a whole set of machining operations program, you could right-click and select generate all or regenerate all, and each of these operations are generated on separate threads, which basically takes advantage of your multi-core processing or multi-thread processing of your hardware and operating system. So I would like to now show one of the new features that's introduced in the 2015 version is the interoperability, where you can take the CAD data and the toolpaths that are programmed in RhinoCAM and export this as a VisualCAD format. So by selecting export to VCP, and this automatically allows you to save this part in here, and you can specify a name for it, and selecting save will save the part, and then you can go back and work with the same part in VisualCAD CAM. So I'm going to switch back in here and click open, and you will notice that the part we just saved is now available in here, which can be loaded in VisualCAD CAM, and you can seamlessly work within the two systems. So all of your information, including the part geometry, the toolpaths, are all transferred over to VisualCAD CAM. The next thing I'm going to show is one of the other modules, which is going to be the turn module in VisualCAD CAM. So I'm going to switch the interface over to turning, and let's go ahead and bring in a part which can give you a quick overview of turning in VisualCAD CAM. Now this can be used for programming your 2-axis turning centers. So the system automatically orients your world X coordinate to your turn Z coordinate and the world Y to your turn X coordinate. So the workflow is typically define your part. So you can either select surfaces or you could select curves, which would be your 2D geometries, to establish the part. So once you define the part, VisualCAM's turn module automatically determines the part profile. The next step is to define your stock material. So you can pick from the available stock types. You can choose a cylinder stock, where you can specify the radius and the length for the stock. If the part has a bore on it, you can specify the inner dimensions for radius and length. In the next step, you would like to establish the work zero, which allows you to set the work origin. So typically it's set to the rightmost face. You can pick that to the right face, and that establishes your work origin. And then you can start programming your turning operations. So VisualTURN offers turn roughing, finishing, groove roughing, groove finishing, follow curve, turn threading, and parting off operations. So I have a few operations programmed in here, and you can go back and make changes, edits to these parameters, and selecting generate computes the toolpath. Once you have the toolpaths programmed, you could go back and run verifications. So I'm going to switch the view to the isometric view in here, so it's easy to view the simulation in turning. Switch to the Simulate tab, and I'm going to switch the simulation display to a 3/4 view so you can get a better view of the stock model, and you can hit the play button to run the verification. So there's your turn simulation of the OD operation, which is the outer diameter, the drilling, the hole making operation, and also the ID roughing and finishing operation. All roughing operations in turning, they take into account your in-process stock, so it knows where there's material being left, so it eliminates cutting any air. Once your toolpaths are programmed, you can generate an information to look at the estimated machining time, and then do a post-process to output the instructions out to your CNC machine tool. And you can also generate a shop documentation very similar to how we did it in the mill module by just right-clicking on the setup or on the machining job to create a shop documentation. Now the exact same features are also available in the RhinoCAM module, where you can switch between the mill and turn module by just a single button click on the machining browser, and you'll notice that the interface automatically switches over to turning. And I'm going to go ahead and load in a turn part. Similar part will be programmed in the standalone system. So the workflow would be exactly the same, very similar, to generate toolpaths either in RhinoCAM or VisualCAD CAM. Now for those of you who are using the Rhinoceros CAD as your main CAD system, it makes it a lot easier to stay within the same system. So if you make a design change, you can just go back and generate your toolpaths. And you can also pick any areas that you want to contain or avoid areas. You can pick avoid sections for the turn operation toolpaths in here. So I can exclude this groove from being machined, and pick generate to generate the toolpath. You can see that the groove is now being excluded from the turn finishing operations. This basically gives you a broad overview of the milling and the turning solutions as offered in RhinoCAM and also VisualCAD CAM. Next, I would like to show you the brand new 3D print module that's being offered in Rhino as well as in the standalone VisualCAD CAM. It's called Rhino 3D Print, and in VisualCAM it's called the Visual 3D Print. So I'm going to go over to a new instance of Rhino here, and I'll switch to the 3D print interface. So we'll click on Rhino 3D Print from the menu bar, and I'll select Browser, and this displays the 3D print browser interface inside of Rhinoceros. So the 3D print module offers a wide range of tools for creating modeling, mesh modeling. You can create mesh from point clouds. You can convert surfaces and poly surfaces that are designed in native Rhino or imported from Rhino into a mesh. And the Modeling tab offers you powerful tools like mesh booleans, unite, subtract, intersection. You can also perform mesh offsetting, splitting, so the offset and split can be used for shelling operations. You can do slicing of mesh geometries. The inspection tools offer you analysis for reflection and curvature lines, and you also have mesh smoothing, remeshing, and reduce mesh. And also the repair tools offers powerful tools like automatically fixing holes, self-intersections in any incorrectly oriented triangles, and also stitch and close to stitch open meshes to a closed mesh, and also diagnosis tools. Finally, the 3D printing tab offers you the ability to select your printer, fit the model to the printer's volume, check for errors, and export it out to your 3D printer. So let's take a look at this workflow here. So I'm going to go ahead and bring in a couple of files. We'll start with this 3D model. This was a toy gun that was built for one of the toy industry manufacturers. And as you can see here, the part shows several different poly surfaces, and it's so complex. There are so many features. Now this part was intended for just, for a rendering application, but was not intended as in terms of design for 3D printing. So how can we make this model good for 3D printing? So first I'm going to do is show you is this part has some moving components in here. So I'm going to have them printed out as separate parts. I'm going to hide those moving components in here. And let's go do some edge analysis in Rhino. So let's do a show edges. So this basically determines any naked edges or open edges that are on the part. You can see that there are several open poly surfaces on the model, so the model is not ready for 3D printing, and there are several different poly surfaces, as you can tell by looking at the model, so it's not easy to fix these using the native tools that are built into Rhino. So the first step in this is I'm going to convert this to a mesh. So I'll use the native Rhino tools to convert it to mesh using mesh from NURBS object. I'm going to go select all of these surfaces in here and use the polygon mesh options to create a mesh. Now once the mesh has been created, I would like to copy this mesh to a new layer. So I'll do a select mesh and copy them over to a new layer. And I'll hide the original geometry. You can see that all the meshes that were created is now populated in the data tree in the Rhino 3D Print browser. And let's go perform a diagnose on it to find out how many issues we have in terms of open edges and other areas. So let's go run a check on it, and you'll find that there's close to about 200 open edges in the model. So let's easily fix that by using the powerful auto fix button. I'm going to just select this here and press enter to run an auto fix. So this automatically fixes holes, self-intersections, and any incorrectly oriented triangles. Now when we perform a diagnose on it again, you will see that there aren't any issues detected. That's great. So since we have so many different closed meshes, I would like to merge them all into one. So I'm going to use the powerful Boolean Unite tool and select these meshes and merge them into one closed mesh. So the Unite is a very powerful process. It's really quick and powerful. As you can see, basically merge it to one mesh, has close to about 180,000 triangles on it. Now let's go run a diagnose on it again to see if there are any open edges. There shouldn't be, and looks like there aren't any open edges on it. So if you want to print this part, and typically you may want to insert like a battery pack or some of those features, so you may want to create some shelling in here, so you want to do some offset on this model here. So now let's go ahead and try to create an offset on this complex 3D model here. We'll go to the Model tab, and we'll use the Offset feature to offset the mesh, and I'm going to specify the parameters for offsets. I want to offset it towards the inside, so I'll specify a negative offset and a tolerance. We'll pick offset. So in this process, it automatically creates a uniform offset of the 3D model, and once the offset process is complete, you will see the original mesh and the mesh that was offset in your data tree right there. So there are the two meshes. Now let's go take a look at this offset mesh by putting in a C-plane in Rhino to take a look at the two meshes in here. So I'm going to introduce a clipping plane, and I'll activate the clipping plane from the perspective view, and you'll now notice that the original mesh and the offset mesh right on the model. There it is, nice and clean. This is a fairly complex process of creating the offset, and you can see how well Rhino 3D Print is able to handle it. Now let me go ahead and disable the clipping plane. I'll also disable it from the front view. And now let's go ahead and split the mesh into two halves. So I'm going to go back into the 4-view layout, and let's take a look at how we can split it. So we'll use the split functionality in here. Select the model, and I can specify the location for the splitting. I want to split it right in the center, so I'll leave it at the midpoint. I'm also going to pick cap results and hit split. Now while we are waiting on the split to complete, since it's a fairly complex model and there are so many areas to be split, it automatically also splits, and since we chose cap results, it's going to fill the gap between the original mesh and the offset mesh. Now while this is being split, I would like to demonstrate some of the other nice features, powerful features in the 3D print product. So I'm going to go ahead and grab one other example to show you how powerful the AutoFix tools are. So I'm going to go grab this model in here, where you'll notice that the mesh geometry has several self-intersections in several areas. Now this offset was created in a different system and brought into it, and as you can tell, there are so many self-intersections on it. So the AutoFix can automatically help you fix these within no time. So when you click on AutoFix and pick the mesh geometry and press enter, you will notice that the AutoFix automatically fixes those self-intersections on all of those areas. Also, I would like to show you the power of stitch and close. So let me go ahead and load this model in here. So this is basically a 3D mold, which basically has several different open meshes. As you can see, it has over 400 different open meshes. And when we run a diagnose on it, you will find that the part has over 34,000 open edges. Now, to fix this manually, it's going to be a very time-consuming process. Now, let's go ahead and run a stitch and close using the 3D print module. We'll select all of the geometries and press enter. And there it is. It's working on the stitch and close, and in just a moment, all your meshes are now stitched to one closed watertight mesh. Rhino 3D Print also offers powerful tools like mesh reduction, so you can select the mesh geometry, and from the Inspect and Modify tab, you can use the Reduce Mesh tool to reduce the mesh by a triangle count. So you can specify if you want to reduce it by about 30%, so it'll reduce it by 30% of the original mesh, and there it is. Also, it offers powerful Boolean tools. Let's say you want to create a negative of this model. You can model a box, and then let's go ahead and do a difference of the two. Let me go ahead and model a box right there, and I'm going to go ahead and do a difference by using model. From the model tab, pick the subtract feature, pick the first set of geometries and the second set, and you'll notice that the Boolean tools are so powerful, and your result of the Boolean is instantaneous right there. So Rhino 3D Print offers a lot of mesh repair tools and mesh fixing tools which will help you prepare the model for your 3D printing. Now, once your model is ready to be printed, you can go to the 3D Print tab. You can select a printer from the list of printers in here. So we have a wide range of printers in here. You can also add more printers to your list. You can select the printers and also display the printer volume. So once you have the printer volume displayed, you can go ahead and align the model to the printer's volume. You can use the fit command to align it, and you can choose from different alignment options. And if you need to orient the part or rotate it, you can use your tools that are available in Rhinoceros. You can use the Rhino's gumball in here and say you want to rotate it by 180 degrees, and there it is. It's flipped over. And in the next step, we could go ahead and perform a check of the model. So to make sure the model is closed and the entire mesh is completely enclosed in the printer volume. It also checks for thin walls and overhangs as well. So once you're satisfied with the checks and results, you could go ahead and pick the export option and export it out to your 3D printer in one of these formats, STL, SLA, or AMF. Now, if you're running Rhino 3D Print or Visual 3D Print on a Windows 8.1 machine, this will automatically have an additional option called Print, and which can load the printer interface within the 3D Print module. So which can basically, it shows your printer drivers, the driver settings, and you can just hit the print button. So it'll transfer the information from your Rhino 3D Print directly out to your 3D printer as well. Now let's go back and check if our split was complete, and looks like it did. And let's go ahead and take a look at the cross-sectional view in here. So there's the model right there, and you can see that the split process resulted in a nice shelling. This can be used for a variety of different applications. You can see such a complex model, we were able to easily offset it, split it, and cap it, and it's now ready for 3D printing. So the same workflow process is also available to you in VisualCAD CAM. So you can click on the Visual 3D Print interface and select the browser, and this displays the browser right here. And all of the mesh modeling tools in Visual 3D Print can be found under the Mesh Modeling tab. And Visual 3D Print offers a wide range of tools, very similar to what we did in Rhinoceros using the Rhino 3D Print product. Now, one of the features I'm going to show you in the 3D Print product in Visual 3D Print is how you can take a scan data like a STL file. It could be scanned from a 3D printer. It could be in a text file or any of these formats. You can bring in those scanned information into into the 3D print product, you can see that this particular model has close to 500,000 points in here. The point data is now loaded, and you can convert this to a mesh using the tools available in the 3D print product and make it ready for printing. Or it could also be used for any other application like milling as well. So you can create mesh from point cloud using from point cloud feature in here, select it, and specify the mesh creation option, and selecting create will allow you to create a mesh from the point data. As we are waiting for this mesh to be generated, I could also show you some of the powerful tools that are offered in 3D print, which allows you to fix the models for 3D printing. So I'm going to bring in a file in here. This is going to be a DXF file which has two meshes, and as you can tell, the meshes in here have a lot of issues where you can see that there are so many open areas, incorrectly oriented triangles. There's two different meshes and both seems to have the same issue. So how easily we can fix it using the 3D print product just by using the stitch and close. We'll select the two meshes and press enter. In just a few seconds you'll notice that the model is now clean, ready, and can be used for your 3D printing or even a CNC milling or routing applications. So there's a wide range of applications. The 3D printing, the mesh tools can be used in Visual 3D Print as well as inside of Rhino. So as you can tell here, the mesh is now ready, and you can see that after the process of creating mesh from point cloud, you'll notice that the mesh has several holes on it, so we can perform a diagnose of these objects of the edges in here to figure out how many open edges you have on the model. And as you can tell, there's close to about 38,000 plus holes, and then you can run an autofix to automatically fix this. Now this basically gives you an overview of the 3D printing product and the CAM solutions that are offered in MecSoft flagship VisualCAD CAM as well as RhinoCAM and Rhino 3D Print. I would now like to pass this over to my manager Anita, who's VP of Sales, who can help you get you more information about both the products.
Thank you, Uday. That was a wonderful presentation. There was so much information there, and I'm sure we have a lot more to share, but only so much time. Now, folks, I'd like to highlight a few details about the products. Uday spoke to you about a lot of them, but a few things. We just released that new 2015 version of VisualCAD CAM and RhinoCAM. The highlight of this release is, obviously, you've seen it, the automatic drilling features. This is our first foray into automatic machining, and we will be extending this functionality over for other milling operations with future releases, so stay tuned for that. We are at a very good spot right now with this functionality. Now, the very exciting new product is our 3D print software for additive manufacturing. You've had a nice preview of this product earlier from Uday. I'm sure there are a lot more questions that you might have about this. We have provided a demo on our website that you can easily download and run, and it is fully functional for a month, so go ahead and try it out. MecSoft is now truly a one-stop shop for all your machining needs. We have the Subtractive solution for you in terms of our milling, turning products. We have the additive manufacturing solution for you in terms of our 3D print software. So, try out all our software, see what you have. I'm sure a lot of you have our milling solutions already, but try out our print product as well. Now, one feature that Uday mentioned, he did highlight a lot during the presentation, was the interoperability between the two products. VisualCAD CAM is our standalone 2 through 5-axis CAD CAM solution. For those of you looking into working with a CAD system with additional design features, you can easily graduate from VisualCAD CAM into RhinoCAD CAM. RhinoCAM offers the same features as VisualCAM, seamlessly integrated with Rhinoceros. Now this provides a very powerful tool set as your CAD-CAM solution. Now point out that now you have a flat learning curve for your CAM. You already have learned your CAM features through the VisualCAM solution. Migrating you to RhinoCAM, there is no learning curve there. And then the interoperability feature between the two programs, where you can bring in the programmed file from one product to the other, very powerful with this new release. And to make it even easier for this transition, we've made it very affordable. You can purchase what is called a bridge license that helps you move from the standalone to the embedded solution in Rhino without having to pay for a whole new license. So now this is a very unique solution offered only by MecSoft. No other CAM provider has the solution for you. Now, I'm sure you all have a lot of questions about our milling, turning, nesting art, and about our additive product that we've just released. Call us, email us. We'd be glad to hear from you and help you out with any questions you have. Now, finally, I'd like to thank you all for attending the session, getting to know our products, and for those of you who already have our products, the new features that Uday highlighted, which should be very informative for you. Last but not the least, a loud shout out to everyone at Novedge, especially Barbara.
Thank you,
for
Anita.
hosting this webinar.
Thank you, Anita. Thank you so much.
You're welcome. We really appreciate all your efforts, Barbara.
Yes,
the stage is all yours now.
Yes, come on over to Novedge for all, you know, the products, the modules, and the pricing. Somebody was interested, and just come over to check our catalog, and you'll find it very appealing. And you were right, Uday was on a roll in this presentation. That was awesome. I just, you know, make sure you 3D print a flower to put in that 3D printed gun. Just, you know, I'm going to take this next webinar, the flower that goes into the gun. I'm going to take my screen back. Sorry for doing that, but I would like to thank everybody for attending. Thank you all from the Novedge team. And here's the page with Rhino 3D Print 2015. Just give us a call. You'll get a great quote. You know, Novedge is the best way to buy design software online. For information on the latest special and new releases, join the Novedge network on Facebook, Google+, or Twitter, and subscribe to the Novedge blog. The upcoming webinar will be Organic Surface Modeling in SolidWorks with award-winning power surfacing from NPower Software. To rewatch today's webinar or previous one, check out our Novedge YouTube and Vimeo channels. Our webinar playlist has webinars for every software taste, guaranteed. Thanks again for joining us, and have a wonderful day. And I want to thank again the MecSoft team, and thank you again for another fantastic webinar. Bye, everybody.
Thank you.
Bye.
Thank you. Bye-bye.